In this video, you guys are going to understand how do we integrate, in the sense the mathematical formulas for the couple of functions, and also not only that, there are certain rules and regulations in how you have to integrate. You guys are going to learn all those things. Fine. Now here, see, the very first thing is when you're different. So we'll start with the derivative because you guys know derivative. Say what we'll do. Say you are going to take d by dx of x to the power of 3. Let's not go for x power n right now. Suppose if you have this, then what do you do? 3 x to the power of 2, correct? Now, if you integrate x square, you should get back x cube, because integration and differentiation are inverse function, right? So now what do we do? So we are going to take integration of 3x square, and this is going to give us x cube, correct? So the most important point is this x square part. X square part. See, 3 is a number, correct? So let's keep the 3 outside and say you are going to take x square. All right. So when you write x square, see, this x square is converting into x cube, right? So the power of 2 is converting into the power of 3. That means the whatever the power you have, we are going to add 1 to the power. If it was 2 on the integration sign, I'll get 3 afterwards, isn't it? So in general, you can write, so no, more than the general case, let's do for this particular case. So what you have, the x square is becoming x cube. So what I'm getting, x to the power of 2 plus 1. Whereas you have this 3 outside, correct? So what you have, 3 times this one, right? But we don't want the 3 because the question is what? Just derivative of x cube. There is no 3x cube. So we need to get rid of this coefficient 3, right? So when you're multiplying by the coefficient 3, what do? We divide by 3. You might be thinking, like, how can we just divide? Not possible. That's why instead of writing 3 here, I'll write this in terms of the power. All right, that means 3 into x to the power of 2 plus 1 divided by 2 plus 1. Okay, that means here 2 plus 1 is 3. 3 and 3 is going to get cancelled, right? So this and this gets cancelled. What do you get now? X to the power of 3. This is basic prod, correct? In general, when you write this, so what do we write as integration of x to the power of n dx. This is equal to, see, the power of n here, 2 was becoming 3. So x to the power of n plus 1, right? Divided by n plus 1. See, exactly like what we did here. 2 plus 1, 2 plus 1, isn't it? N plus 1 plus c. In the last video, you guys saw the integration constant. There is a condition here though. The condition is n is not equal to minus 1. Otherwise, the denominator would become 0. That's why we don't do it. All right. Now, whatever you have right now, this is the integration formula. Now, let's take one more example, which is a very, very known example. All right. See, if you take, let's say, derivative of sin x, very simple. D by dx of sin x is nothing but cos x, correct? So what is integration of cos x then? So integration of cos x, this is going to become sin x. But it won't be just sin x, it will be sin x plus c. Okay, now what if you have derivative of cos x? This is going to be minus sin x, correct? Now integration of minus sin x is going to become cos x plus c, correct? But we don't want integration of minus sine x. We generally want the integration of sine x. That means integral of sine x. Take the minus sign this side. It's going to become minus cos x plus c. See, this is what we have. Okay. Now do you understand why derivative and integrals are, inverse functions or inverse of each other? You take the derivative, you'll get one value. Integrate it, you'll get back the same thing. Understood, right? So, what you have right now, so you might be seeing this on the screen, that these are the list of formulas what you have. Now, if you look at it carefully, you have polynomial functions like x to the power of n. You have trigonometric functions, sine, cos, tan and all. You have inverse trigonometric functions, correct? So you have all these functions, log, that, this and all, everything you have. So just remember the formulas of these integration, because one, if you know the derivative, you can get the integral. That's why even the derivative is also given to you, not just the integral part. So you have the derivative, you have the integral, you can match, right? Generally, knowing the integral is a lot more easier, and also it's more preferable. Fine. Now, let's discuss. There are certain rules in which you have to integrate. Okay, there's certain rules and regulations. Let's do those rules first. All right. When I say rules of integration, so how exactly you are going to take if you have two functions or two or more functions? Okay, the first one you can say is that suppose if you have f of x plus or minus g of x, integration of this one dx, integration of f of x dx plus or minus g of x dx. That means you can split the integral. Fine. Now after this, suppose if you have, let's say, a constant, say lambda into f of x dx, you can keep the lambda outside f of x dx. Fine. So this is another very important factor what you have to know. Okay. Now whenever you integrate, that means, see, if you write integration of f of x dx, let's call it as capital F of x plus c. The plus c is a very important point. Okay. See, now what's happening? The what we call it as, this is what we call as integrand. Okay, integrand. Then the next one, dx and x. Very, very important. Dx is with respect to what variable you are integrating. So if you write dy, you're integrating with respect to y. If you write dz, you're integrating with respect to z. So that dx, dy, dz, whatever you have, that tells you what is the variable in the function. It's a very important parameter. Okay. Then finally, you have the c, which is the integration constant. Fine. So these are certain parameters and certain rules, you can say, where you can apply these rules whenever you're solving problems. Okay. Now first we'll do few basic problems in the next video. Then after that we'll look into different methods of solving integration. Fine. So we'll start with very basic problems in calculating the antiderivative from the next video.